Hello students, welcome back to the lecture. So in this series we are studying NCERT class 11th first chapter, that is sets. So continuing from the previous lecture, today we'll be studying about some interesting facts about sets, and this is going to be one of the sections from where the competitive examination also asks a lot of questions. So in sets, earlier we studied about two representations. One representation was roster form and another representation was set builder form. Today we'll be talking about a way of representing sets pictorially, and that representation is done through Venn diagrams. All right. So let's study about Venn diagrams first. So we have most of the relationship between sets can be represented by means of diagrams which are known as Venn diagrams. Right. So we do represent sets by another method other than the two that we have studied earlier, and that is through Venn diagrams. So Venn diagrams are named after the English logician named John Venn. So John Venn was an English logician, and he basically gave us the idea of representing sets through these series of diagrams we call as Venn diagrams. Now, what exactly is there in the Venn diagram? These diagrams consist of rectangles and closed curves, and these closed curves are usually circles, right? These closed curves are usually circle. The rectangular part, so suppose this is the representation. So there is a rectangle here, and there is a closed curve, which is a circle. Usually this rectangular part represents the universal set. Universal set. We studied about universal set in our last lecture, right? And this circular closed curve basically represents the set or the elements inside it, right? So for example, let us take an example and try to understand. So suppose this is the universal set given to us. In the universal set, we have numbers, natural numbers from 1 to 10, right? Another set A is something that we have represented through with all the even natural numbers from 1 to 10. So you have 2, 4, 6, 8, and 10. Now, if you see closely, this set A is nothing but a subset of this universal set. So what we do is, we represent this universal set, write all the elements inside it, and then in the set A, we basically include the elements which are there in the set A. So here you'll see some of the elements of this universal set belong to the set A, and some elements are outside this set, right? So this is how we represent. We represent the universal set by a rectangular box, and we represent the set, which is a subset of this universal set, through closed curve or preferably a circle, right? Now let's see another illustration. Suppose again you have this universal set where you have numbers from 1 to 10, natural numbers from 1 to 10. We have been given two sets. One is where you have 2, 4, 6, 8, and 10. That is set A. And then you have another set B which have 4 and 6 inside it. So if you see, if you compare the set A and B, clearly all the elements of B are there inside set A. So we say that B is a subset of A, right? So B will be a set which is basically inside the set A, as all the elements of B are also there in set A. So here we have represented B, and in B there were two elements, 4 and 6. In set A we had 2, 4, 6, 8, and 10. Clearly, you can see that this 8 and 10 are lying outside this set B. That means 8 and 10 are elements of A, but they are not an element of B. And the universal set, if you see, you have 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So you have set A, which is a subset of this universal set. Set A is a subset of this universal set. Simultaneously, you also have B as a subset of universal set. B also is a subset of A. So clearly you can see that there are some elements in this universal set, which are neither element of B nor element of A, right? So here is what we usually do whenever we represent a set by Venn diagrams, right? Now let's talk about the operation on sets. See, when we were talking about real numbers or natural numbers, there were a lot of operations that we used to do on those numbers. For example, we used to add them, we used to multiply, we used to subtract, and things like that. So on sets also, there are some operations that we do, right? And in this section, we'll be studying about what are those operations that we will be doing on the set, right? So the first operation that we do is union of sets. Now let's try to understand what exactly is union of two sets. So usually whenever we talk about operations, this operation is always conducted on, a group of sets. So it could be a pair of two sets, it could be three sets, and so on. So in usual sense, that is in the boundaries of our syllabus, we usually, do these operations on either two or three of the sets, right? So let's try to understand union of sets first. So let A and B be any two sets. The union of A and B is the set which consists of all the elements of A and all the elements of B. And the common elements being taken only once, because we have seen in the definition of set that usually we do not repeat elements inside a set. So ideally in union, what we are doing is, if you have two sets given, we are trying to combine all the elements of these two sets and making a set out of them. Now let's see with an example. So for example, you have set A given as 2, 4, 6, and 8, which are the elements inside A. We have set B, which have elements 6, 8, 10, and 12. And we have to find the union. We usually represent union by this symbol. This symbol is basically used for the term union, right? And if we have to write union of two sets A and B, we write it as A union B, right? A union B, and is usually read as A union B, right? Okay, now let's see the example. So here you have two sets. Set A has 2, 4, 6, and 8 as an element, and set B has 6, 8, 10, and 12 as elements. And we wanted to find the union. So in this union, what we are trying to find is a set which has all the elements of A and which has all the elements of B. But at the same time, we try to maintain the fact that we do not repeat an element inside the union that we are trying to find. So if we try to find the union of A and B, we will try to include all the elements which are inside A. So you have 2, 4, 6, and 8. So 2, 4, 6, and 8. This will be inside the union. But in set B, other than 6 and 8, we also had 10 and 12. So these two will also be elements inside the union, right? Now, if you see this set is basically formed as a combination, or formed as sort of combining the two sets A and B, right? And if you see, all the elements of A are there inside this union, all the elements of B are there inside this union, and we have also made sure that we are not going to repeat any of the common elements which are there inside A and B. We knew that 6 and 8 are the common elements in A and B, so we have included 6 and 8 only once, right? So this is how you find the union, right? Let's see another example. Here you have set A having all the vowels inside it, A, E, I, O, U. You have another set B which have, elements as A, I, and U. Now, if you want to find A union B, that means we are trying to find a set which contains all the elements of A and which contains all the elements of B. So here, if I add all the elements of A inside this set, then you have A, E, I, O, and U, right? But if you have written all the elements of set A, you can clearly see that the elements of set B are already written inside it. So you already have A inside it, I inside it, and U inside it, right? So if you form this set, in this set, there are all the elements of A and there are all the elements of B, right? So this will be nothing but your A union B. But if you try to see, this A union B is nothing but the set A itself, right? The A union B is nothing but the set A itself. So this is nothing but the set A. Now, what exactly are we trying to, infer from this case is, now if you see carefully the two sets A and B, you can clearly see that all the elements of set B are there inside set A. So here you have B as a subset of A. So whenever you have this case, when one of the set is a subset of another set, then if you take the union of the two, you'll be getting the bigger set as a resultant. So if B is a subset of A, and if you try to find A union B, you'll get your answer as set A itself. For another example, let us say if you have P as a subset of Q, right? And if you try to find P union Q, you'll get your answer as set Q itself, right? So here is what is the explanation given. This example illustrates that the union of set A and its subset is the set A itself. That is, if B is a subset of A, then A union B will give you the larger of the two sets, that is set A, right? Now let's see the example 14. So you have set X given as Ram, Sita and Akbar be the set of students of class 11th who are in school hockey team, and let Y is a set having Geeta, David and Ashok be the set of students from class 11th who are in school football team. Now you have to find X union Y. I hope you will be able to find X union Y because this set is going to contain all the elements from X and all the elements from Y. So if you see all the elements from X being Ram, then you have Geeta, and then you have Akbar, right? So these are all the elements of set X. Now we also have to include the elements of set Y, but in set Y, Geeta is there, and we have already included Geeta. So we are not going to repeat Geeta inside this set. The remaining two, that is David and Ashok, are definitely going to be here in the union because they were not inside set X, right? So you have David and Ashok. So this set that you have gotten is nothing but X union Y, right? So idea is very simple. In union, you try to include all the elements which are there inside all the sets all the sets on whom or all the sets on which you have taken the union, right? Okay. Now let's try to define the union of two sets formally. So the formal definition says that the union of two sets A and B is a set C. That means if you take union of two sets, the resultant is also going to be a set which consists of all those elements which are either in A or in B, including those which are in both. That means you have to include all the elements inside A and you have to include all the elements inside B, making sure that the common elements between A and B are written only once. So symbolically, if you try to write, A union B is a collection of all the X's where you have X belongs to A or X belongs to B. Now this statement itself is very interesting. And this word is also very interesting, or, right? Whenever you write or, so if you try to see this statement carefully, this is a combination of two statements. In one of the statements, you are trying to say X belongs to A. In another statement, you are trying to say X belongs to B. So there are two independent statements inside this compound statement, and they are connected with a word or, right? Now, if we try to find the truthness of this composite or combined statement, it is usually found by whenever the connector or connecting word is or, the entire statement is true if any one of the statement is true, right? So if X belongs to A, this entire statement will become true. If X belongs to B, this entire statement becomes true. And if X belongs to A as well as X belongs to B, this entire statement is again true. That means whenever two statements are connected with the word or, the truth of the statement can be established by the fact that at least one of the two independent statements should be true. So this is false only if both the statements are true, are false. So this statement, this combined statement is false only if this is also false and this is also false. If any one of them is true, then the combined statement is true, right? All right. So here again, let's try to explain. Whenever you are trying to find A union B, you are trying to include all the elements of A and you are trying to include all the elements of B, right? Okay. So if you try to represent this union of the sets by a Venn diagram, right? So suppose this is set A and this is set B, and you are trying to include all the elements in the union, right, which are there in set A and there in set B. So this shaded region is what the union represents, the entire shaded region. This section, if you see, holds an importance because this section represents the elements which are common to both A and B. Elements which are common to both A and B, this region. And in a short while, we will also see that this also can be represented by a specific operation on two sets, right? Okay, now let's try to understand some properties of union, right? So the first property is the union of two sets follow commutative law. That means A union B and B union A both are going to give you the same set, right? The second is associative law. Associative law means that if you have three sets and you are taking union of the first two in first step, so this is a set that you have gotten. Say if we say that this set to be P, and if you take union of this P with the set C, so the resultant set that you are going to get is going to be same as if you take the union of B and C first and then take its union with A. So irrespective of the order of association, the resultant of the two sets are going to be same. That means A union B union C is going to be equal to A union of B union C, right? The third one is called law of identity. That means if you take union of any sets with an empty set, you'll get the set A itself. And precisely so, because we know that phi is nothing but a subset of set A. And in the previous statement here, we clearly understood that if P was a subset of Q, then P union Q was nothing but the set Q itself. So using this analogy, we can here again say that since empty set is a subset of A, so if you take A union the empty set, you'll get the set A itself, right? Using the same conclusion that we drew little while earlier. And then you have idempotent law. So if you take union of any set with itself, you'll get the set A itself. And this again follows the same rule, since we know that every set is a subset of itself. So if you take the union of the two, you'll get the larger of the two sets. And in this case, both the sets being same, you'll get the set A itself, right? And then if you take union of any set with the universal set, you'll get the universal set, as you know that the set A is going to be a subset of the universal set, right? So if you take A union U, you'll get the larger of the two sets, that is U. That means the universal set. All right. So I hope union is very clear to you. I'll just explain it in one statement. If you take union of two sets, you are basically trying to include all the elements from the two sets inside a single set, making sure that none of the elements which are common to the two sets are repeated in the new set that you have formed. All right. Now let's talk about intersection of sets. So the intersection of sets A and B is set of all the elements which are common to both A and B. So that means in intersection, what we are trying to find is, we are trying to find the set which has the common elements between A and B. And the symbol that we use for intersection is this, right? So the symbol which is used for intersection is this. So whenever we write A intersection B, so that means we are trying to find the common elements which are there in A as well as there in B. So that means we are trying to find all the set of x's which are there in A and simultaneously which are there in B, right? Okay. So the next example is, consider set A and B of example 12. Find A intersection B. So let's go to example 12. So here you have example 12. Here we are trying to find A union B, right? Here A intersection B. A intersection B is going to be a set which has the common elements between A and B. So what are the common elements between A and B? It is 6 and 8. So this will be your intersection of the two sets, right? Similarly, in example 13, if you see, if you try to find the intersection of these two, so you have A intersection B. So the common elements, if you see, common elements are going to be A, I, and U, isn't it? Now here also we try to understand an interesting fact. Since in this case, B was a subset of A, so the intersection of two sets is going to give you the smaller of the two sets, that is B. So in this case, if you see P is a subset of Q, and if you try to find P intersection Q, then you are going to get the smaller of the two sets, that is P. That means whichever set is on the left side of the subset symbol is going to be your answer, right? Okay. Now again, consider the set x and y of example 14. Find x intersection y. So let's see example 14. So example 14, you are trying to find the intersection of these two. That means you are trying to find the common element between the two sets. So in this case, you can clearly see there is only one common element, and that common element is Gita, right? So this will be only a set containing just one element. So it will be a singleton set, and it has only Gita inside it, right? So very clearly, intersection is where we try to find the common elements between the two sets. Let's see example 17. In example 17, you can clearly see you have been given two sets A and B. Here if you see carefully, 2 is there in B, but 2 is also there in A. 3 is there in B, 3 is there in A also. 5 is there in B, 5 is there in A, and 7 is there in B, so 7 is also there in A. So here we can clearly see that B is a subset of A. And we studied just now that whenever you have B as a subset of A, and when you try to find A intersection B, you'll get the smaller of the two sets, that is B here, right? So this is what you are getting as an answer, right? So whenever you have B as a subset of A, then A intersection B is going to give you the smaller of the two sets. That means the set which is on the left-hand side of this subset operation, right? So if you want to define the intersection of two sets in formal language, the definition will be The intersection of two sets A and B is a set of all those elements which belong to both A and B, right? And symbolically, if you try to write, A intersection B is nothing but the collection of all x's such that x belongs to A and x belongs to B. Now here also, if you try to understand, this is again a compound statement having two different statements, that is x belongs to A and x belongs to B. And here the connecting word is and. So whenever and is the connecting word, the truth of the compound statement is going to be established by the fact that both the statements should be true simultaneously. So this compound statement is going to be true when this is true as well as this is true at the same time, right? So just keep this in mind. And pictorially, if you try to identify the intersection of two sets, so it is basically the common region between the two sets in the Venn diagram. So common region between the two sets in the Venn diagram is the intersection of the two sets, right? Now, there could be cases when you have A intersection B as a null set. So, whenever you have this case A intersection B as null set, that means there are no elements in A and B which are common to each other, right? That means there is no overlapping region like this when you draw the Venn diagram of the two sets. So it will be something like this. So you have set A, you have set B. There is no region which overlaps between the two sets. So that means the intersection of these two sets does not give you a unique element. And when there is no element inside the set, then it is a null set. So in this case, we call the two sets by a special name, and that is called disjoint sets. So whenever you have no element common between two sets, then the sets are said to be disjoint sets, right? So for example, suppose this is one of the set where you have 2, 4, 6 and 8, and another set is B where you have 1, 3, 5 and 7. So if you see, the intersection of these two sets is going to give you a null set, and that is why these two sets will be called as disjoint sets, as there are no elements which are common between A and B, right? So this is how we represent disjoint sets on a Venn diagram. If we try to understand some properties of intersection, so like union, intersection is also commutative. That means A intersection B is going to be equal to B intersection A. The intersection is again associative. That means if you take intersection of A and B first and then take its intersection with C, so the resultant set that you are going to get is going to be same as if you take intersection of B and C first and then take its intersection with A. So both of them are going to give you the same resultant set. If you take intersection, of a null set with any given set, you'll get the null set as your answer. And we can clearly see from the theory that we studied here. So whenever you have B as a subset of A, then A intersection B will always give you the smaller of the two sets. That means the set which lies on the left-hand side of this subset symbol. So using this, since we know that phi is a subset of A, so when you take intersection of phi and A, you'll get the smaller of the two sets, that is phi, right? Similarly, you know that A is a subset of union set or universal set, then A intersection universal set is going to give you the smaller set of the two, that is the set A itself, right? And A intersection A, so if you take intersection of the same set with itself, you will be getting the resultant as A itself, right? This is very obvious. All right, now the fifth one is relatively interesting. The fifth one says that if you have A intersection of B union C, So this intersection symbol gets distributed over this union symbol. Let me tell you how exactly we interpret it in terms of mathematics. So this intersection gets distributed over this union symbol. That means first you take A intersection B, union, and then you take A intersection C. So you distributed this first on B, keeping this union symbol as it is, then you distributed it on C. So you have A intersection B, union A intersection C. So this is called the distributive law. Just to, make it strong for you, these two symbols, this union and intersection, can be interchanged as well. That means here we have distributed intersection on the union of two sets. We can also distribute union on intersection of two sets. So for example, if you have P union Q intersection R, so in this case, this union will be distributed over Q and R, keeping this intersection as it is. So you will have P union Q, right? An intersection of P union R, right? So this intersection and union symbol can be interchanged with each other. So here we have distributed intersection over union. Here we have distributed union over intersection. So this is something that we should always keep in mind, right? Now let's try to understand few examples from Venn diagram. Suppose you have three sets A, B, and C. And in this case, you are trying to find B union C. That means you are trying to include all the elements which are there in C and which are there in B, right? If you try to find A intersection B, that means you are trying to find the elements which are common in A and B. So in A and B, these are the elements which are common, right? If you try to find A intersection of B union C, A intersection of B union C. Now here, what you are doing is, first you are taking you can do it in two ways. First is, you can also use the distributive property. That means you are taking you are distributing this intersection over B and C, right? So you'll get A intersection B union A intersection C, right? So A intersection B is the elements which are common in A and B, and A intersection C are the elements which are common in A and C. And you are taking its union, that means you are including all the elements which are in this region, right? If you try to find A intersection C, that means you are trying to find the elements or the region which are common to both A and C, right? If you are trying to find A intersection B union A intersection C, this could also be written as A intersection of B union C. See, you have distributed this intersection over union of B and C, right? So you'll get A intersection B union of A intersection C. And this is what we also saw in this example, the second one. So second one and fifth one are going to give you the same result. That means this region, right? Because both of them represent the same quantity. All right, moving forward, we have difference of sets. Now the difference of sets A and B in this order. So here, whenever we are talking about difference of sets, the order is going to be very important. That means whether you are taking difference of A and B or you are taking difference of B and A, that is definitely going to matter, right? So when you are talking about difference of set A and B in this order is the set of elements which belong to A but not to B. And symbolically, we write this as A minus B. Now let me explain it to you. Whenever you are trying to find A minus B, that means difference of set A and B. So here what you are trying to do is, you are considering all the elements of A and you are taking out all the elements of B which are common in A and B, right? That means you are taking out all the elements which B could have. So for example, let us see with an example. Suppose this is a set A and this is a set B, and we are trying to find A minus B. So in A minus B set, we are going to have all the elements which are there in A but not in B. So which are the common elements between the two sets? You have 2 common between the two sets, 4 common between the two sets, and 6 common between the two sets. So when you are trying to find A minus B, you will include all the elements inside A and remove all the elements which are common to A and B. So the remaining elements that you get is going to be your A minus B. So the remaining elements in this case are going to be 1, 3, and 5. Right? So this is your A minus B. Now if you try to find B minus A, in this case, you are trying to include all the elements of B and taking out all the elements which are common between A and B. Right? You are taking all the elements of B and you are taking out all the elements which were there in A also. So in this case, clearly you had 2, 4, and 6 common between A and B, and only 8 was an element which was there in B but not in A. So here you have only 8 as your result. So that means this A minus B represents a set containing elements which are there in A but not in B. Right? And similarly, when you are trying to find B minus A, so we are trying to include all the elements, or you are trying to represent a set containing elements which are there in B but not in A, right? But not in A. And since this is and this is how you'll get your answer. So you have your A minus B as 135 and you have your B minus A as only 8. Now if you see carefully, this A minus B and B minus A are not same, and that is why order is important. So whether you are finding A minus B or B minus A, the order is going to be important, right? So if you change the order of the two sets, the set is also going to change, right? So clearly you have A minus B not equal to B minus A. So always keep this in mind. So it is not something that we studied as a normal subtraction between two numbers. So if A and if X and Y are two numbers, then X minus Y was equal to Y minus X. But when it comes to set, this is not true. Not true for sets, right? So just keep this in mind. Okay, now let's see some examples. So you have a set V given as A, E, I, O, U. You have another set B given as A, I, K, and U. So we wanted to find V minus B. That means we want to include all the elements of V and we want to remove all the elements which are common between V and B. So if I try to find V minus B, first let's identify which are the elements that are common. So you have A common in the two sets, I common in the two sets, and U common in the two sets. So V minus B will have all the elements inside V minus the elements which were common. So this will have only two elements, that is E and O. And similarly, if you try to find B minus V, in this case, you are going to include elements of B but remove the elements which are common in the two sets. So I'm going to remove A, I, and U. So only K is going to be my element inside B minus V, right? So mathematically, if you want to represent A minus B, so A minus B is basically collection of all x's, right? Where x belongs to A and x does not belongs to B. That means you include all the elements which are there in A and remove all the elements which are there in B, right? Pictorially, if you try to represent A minus B, so A minus B, you wanted to include all the elements inside A, but you want to remove all the elements which are common to A and B. So that means this section we are not going to include. So this section that we are getting is basically representing your A minus B, right? And similarly, if you try to write what this section is going to be, so this section is nothing but you are including all the elements of B and removing all the elements which are common to A and B. So this section is going to give you your B minus A, right? So just keep this in mind. Okay. Now, if you see, this set was basically your A minus B. This set was, so let me highlight it. This set was your A minus B. This set was your B minus A. And this set was your intersection B, isn't it? So this set was A intersection B. Now, if you see between these two sets, that means A minus B and A intersection B, there is nothing common between the two. Similarly, between A intersection B and B minus A, there is nothing common between the two. And similarly, between A minus B and B minus A, there is nothing common between the two. So we can say that A minus B, A intersection B, and B minus A are mutually disjoint sets, right? Mutually disjoint sets. That means if you take intersection of these two, you'll get your resultant as phi, that is a null set. If you take intersection of these two, you'll get your resultant as phi, again null set. And if you take intersection of these two also, you'll get your resultant as phi, which is a null set. So that means these three sets are mutually disjoint, right? Okay, now let's go and solve some questions. So the first question is, find the union of each of the following pair of sets. So let's try to find the union. So in this case, X union Y is going to have all the elements which are there in X and Y, right? So here you have 1, you have 3, you have 5. So I have included all the elements of X. Now I also have to include elements of Y, but I have already included 1, already included 3. So I'll also have to include 2, and this is how you'll get your union. Similarly, in this case, A union B, I have to include all the elements of A. This should be curly bracket. So you have A, E, I, O, U. And you have to also include the elements of set B. I have already included A, so I have to include B and C as well. So B and C. So this is your union. Now let's see these two. X is a natural number and multiple of 3. And here you have X is a natural number less than 6, right? So you have to find the union of these two. So X is a natural number and multiple of 3. So this set is going to have 3, 6, 9, 12, and so on, right? And here you have X is a natural number less than 6. So you have 1, 2, 3, 4, and 5. Now, if you want to take the union, you have to take a set which contains the element of both of these sets. So you have to include 1, 2, 3, 4, 5, and from here, all these elements are going to be included. So you have 6, you have 9, you have 12, and so on. Correct? So this is your answer. Now for this one, X is a natural number and it lies between 1 and 6, 1 not included and 6 included. So you have 2, 3, 4, 5, and 6. And this is a natural number between 6 and 10, both excluded. So this is 7, 8, and 9, correct? And if you have to take the union of the union of the two is going to yield a set which contains the element of both these sets. So you have 2, 3, 4, 5, 6, and then you also have to include 7, 8, and 9, right? So this will be your answer. You have a set A and set B. We have already seen that the union of the two sets, since phi is a subset of A, the union of the two sets is going to give us the larger of the two sets, that is set A in this case, and here you'll have your answer will be the set A which contains elements 1, 2, and 3, right? Okay, now here you have A and B given as two sets. Is A a subset of B? So clearly A, the elements of A are there, completely there inside set B. So yes, I can clearly see that A is a subset of B. And if you try to find A union B, as we have seen that the resultant is going to be the larger of the two sets, your answer will be set B, right? So if A and B are two sets such that A is a subset of B, what is A union B? The larger of two sets, that is B, right? Okay. Now here you have A, B, C, and D. Find A union B. So in A union B, we are trying to find all the elements which are there in A as well as there in B. So let's include all the elements of A. So you have 1, 2, 3, and 4. And you also have to include the elements of set B. 3 we have already included. 4 we have already included. So 5 and 6 are also going to be included in this answer, right? Let's talk about A union C. So A union C, combination of these two. So you'll have your all the elements of A, that means 1, 2, 3, and 4, and all the elements of this. So 5, 6, 7, and 8, right? Similarly, I think you'll be able to find B union C, B union D, A union B union C, A union B union D, B union C union D, and so on. Let me know if any of the answers that you are not able to get. If you are not able to get, we will be discussing in the next class. So in the comments, if you are not able to get answer of any of the remaining ones, do let me know that which are the sections or which are the numbers that you are not able to get the answer. In the next class, I'll be taking those questions as an illustration and will try to solve it for you, right? Now let's talk about this intersection part. So A intersection B, that means we have to find the common elements between A and B. So let's see, what are the common elements? I can clearly see that 7 is an element which is common between the two, and 9 is an element common between the two, as well as 11 is the element that is common between the two. So in this set, you will have 7, 9, and 11, right? Because in intersection, we try to find the common elements between the two sets. Similarly, B intersection C. So B intersection C, we have to find what are the elements that are common between B and C. So let's see. I can clearly see 11 to be common and 13 to be common, right? So here you'll have 11 and 13, correct? Then let's talk about the third one. A intersection C, intersection D. So let's find A intersection C first. So A intersection C is going to give you only one value. The only number which is common between the two, that is A and C, is 11. So this A intersection C is going to give you only will be giving you a singleton set, and this singleton set have only one element, that is 11. Now you have to find the intersection of these two, that means this set, and you have to take its intersection with D. But here in these two, no element is common, right? So 11 is here and 15 and 17 here is here. So there is nothing common between the two. So you have 5 as your answer. A intersection C, common elements between A and C, you'll be able to get only one element, that is 11, right? B intersection D, you have to find common element between B and D. Clearly, B and D does not have any common element because in D only two elements are there, 15 and 17, and they are not present in B. So your B intersection D is going to be 5. A intersection B union C. So first we have to take the union of these two sets, right? So B union C is going to give you a result where you have 7, 9, 11, 13, and then you have to take union with C. 11 and 13 is already we have included, so we have to include 15 also. So this is B union C, and we have to take the intersection of this set with A. That means we have to take common element between this set and set A. So common element between this set and set A is going to be 7, 9 and 11, right? 7, 9 and 11. So your final answer for sixth is going to be 7, 9 and 11, right? Let's try and find the seventh one. Seventh, you have A intersection D, common elements between A and D. Obviously, no common elements, so you have 5. The eighth one is you have to take B union D first. So let's try to find B union D. So B union D is going to be a set which have all the elements of B, that is 7, 9, 11, 13, and you also have to include the elements of D, that is 15 and 17, correct? So this is B union D. Now you have to take the intersection of B union D with A. That means common elements between this set and this set. So the common elements are 7, 9 and 11. So this is also something you'll get 7, 9 and 11, right? Then you have A intersection B. So A intersection B, let's try to solve this separately. So A intersection B will be a set that is common elements between A and B. So the common elements between A and B is 7, 9 and 11, right? And then you have to find B union C. That means you have to take all the elements which are there in B and which are there in C. So you have 7, 9, 11, 13, and in C also you have to include all the elements. 11 and 13 we have already included, so we have to include 15. Now you have to take the intersection of these two sets. So intersection of these two sets are the common elements between the two, so you will have 7, 9 and 11 as your final answer, right? So this is how you find the intersection and union of two sets. Going forward, let's solve question number 7. So 7 is X is a natural number, right? A is a set and it is a set of natural numbers. B is an even natural number, right? And C is the set of odd natural numbers. And D is a set of prime numbers. Now let's understand. So this is a set of natural numbers, right? Even natural numbers is basically a subset of a set of natural numbers. So B is a subset of A. Similarly, odd natural numbers are also a subset of natural numbers. So C is also a subset of A, right? And D is the set of prime numbers. So D also is a subset of A because all prime numbers are natural numbers, right? Now you can also see that B is the collection of all even numbers and C is the collection of all numbers. So clearly these two sets are not going to have anything in common. So I can clearly see that B intersection C is going to be phi. That means these two are disjoint sets, right? Now let's try to figure out what is the answer of these questions. So you want to find A intersection B. We know that B is a subset of A and you are taking the intersection. So the answer is going to be the smaller of the two sets. That means the set which lies on the left side of this subset symbol. So your answer is going to be B. A intersection C, again C is a subset of A. So your answer will be going to be, answer is going to be the smaller of the two sets. So answer is C. A intersection D, again D is a subset of A. You'll get your answer as D. B intersection C, we have already established the fact that these two does not have anything in common. So this will be your phi. Now B intersection D, so you have B as a set of even natural numbers and D as a set of prime numbers. So what is common between these two? So we know that all the prime numbers other than 2 are all odd. So the common between even natural number and a set of prime number is just the element 2. So 2 is the only element which is even and which is prime, right? C intersection D. C intersection D basically will give you all the odd prime natural numbers. So odd prime natural numbers are, you start with 3, you have 5, you have 7, then the next odd prime number is going to be 11, then the next odd prime number is going to be 13, then the next odd prime number is going to be 17, and so on. So this is your answer, right? All right. So in the eighth question, we have to identify which of the following pair of sets are disjoint. Disjoint means they should not have any element common, right? They should not have any element common. So here, the first set is given in roster form. So clearly I can see that the elements are 1, 2, 3, and 4. The second set is in set builder form, and it is a set of natural numbers, and these natural numbers are lying between 4 and 6, both included. So this is a set, if we want to write it in roster form, so have elements 4, 5, and 6. Clearly I can see that there is an element common between the two, and that is 4. So clearly this, suppose this is set A given and this is set B given. So we have A intersection B not equal to 5. And when not equal to 5, so this is not disjoint. This pair is not disjoint. If you see these two, so I can clearly see there is E common between the two. So again, not disjoint, right? Here you have X as a set of all the even integer and X as a set of all the odd integers. So clearly we know that there is nothing common between even and odd integers, because there is no integer which is even and odd at the same time, right? So this is basically a disjoint set. Now here I want to ask a question from you, right? And this will basically test that whether you have taken the previous classes, that is 7, 8, 9, 10, seriously or not. Usually we have a confusion, and the confusion is usually about the number 0. Now my question to you is whether 0 is an even number or whether it is an odd number. So I have three options for you. 0 is even, right? This is first option. 0 is odd. This is second option. And 0 is neither even nor odd. Now, which one of the options will you choose as your answer? Many students I have asked have always chosen neither even nor odd as their answer. But let me tell you, this is a wrong answer. 0 is an even number. 0 is an even number. How? Let's go into the definition of even numbers. So what is an even number? Even number is any number which when divided by 2 gives a remainder 0, right? Any number which when divided by 2 or any number which when divided by 2 gives a remainder 0, right? That is an even number. So if you have 0, right, and if you divide it by 2, right, the remainder is always going to be 0, right? So this basically satisfies the definition of even numbers, right? So if you have confusion that whether 0 is even, odd, or neither even nor odd, always keep in mind that 0 is an even number, right? So there is no intersection or there is no element common between the two sets. So that is why these two sets is a disjoint set or a pair of disjoint sets. All right. Okay. Now here you have 4 sets given. We wanted to find A minus B. I'll solve one or two of these and I'll leave the rest for you to solve. So if you want to find A minus B, so you are going to include all the elements of A and you are going to exclude the elements which are common between A and B. So let's see which are the elements that are common between A and B. So I can clearly see that 4 is not common between the two, 8 is not common between the two, 12 is common between the two, right? 16 is not common between the two and 20 is not common between the two. So in this case, we have to include all the elements in A, removing the element which are common between A and B. So this set A minus B is going to be your set containing 3, 6, 9, 15, 18 and 21. So this is your A minus B. Similarly, if you try to find A minus C, so let's try to identify that which are the elements common between A and C first, right? So 2 is not common between the two, 4 is not common between the two, 6 is common between the two, right? 8 is not common between the two, 10 is not common between the two, 12 is common between the two, 14 again not common, 16 again not common. So here in A minus C, you'll include all the elements of A and remove the elements which are common between the two sets. So you have 3, 9, 15 and 21, right? Sorry, 15 was common, I guess. No. Only 6 and 12 were common. So you have 15, 18 and 21. 15, 18 and 21 as your answer. So I hope you will be able to find the others. So I'll leave it for you as an exercise to find. If you again find any difficulty in finding any of the answers, do let me know in the comment and I'll take it as an example in my next lecture, right? Similarly, if you want to find for these two sets, x minus y. So let's find which are the elements common between the two. So you have b common between the two, then you also have d common between the two. So when you find x minus y, you have to consider the elements of x and remove the common elements. So you'll have only A and C as your answer. When you have y minus x, that means you have to include the elements of y and remove the elements which are common between x and y. So in this case, you have f and g to be considered as the element of y minus x, right? X intersection y, the common between the two. So you have two elements common, that is b and d. So this will be your answer, right? Okay, let's see the 11th one. If R is a set of real numbers and Q is a set of rational numbers, then what is R minus Q? That means from the set of real numbers, you are removing all the set of rational numbers. So set of real numbers, you are removing all the set of rational numbers. So this will give you the set of irrational numbers, isn't it? Because we know that rational numbers and irrational numbers together gives you the set of real numbers. So if you remove all the rational numbers from set of real numbers, then you are going to get set of irrational numbers, right? Here we have to say whether each of the following statement is true or false, right? So this and this is disjoint. Are disjoint sets, I can clearly see that 3 is common between the two. So this is a false statement. This and this are disjoint sets. Clearly A is common between the two. I am not going to see about the rest because two disjoint sets cannot have an element common between the two. Here you have 2, 6, 10 and 14. Here you have 3, 7, 11 and 15. Clearly no element is common between the two sets. So yes, these two are disjoint sets. Here also, if you can see, none of the elements between the two sets are common. So this is also a pair of disjoint sets. So I hope you have understood in this lecture about Venn diagrams, about operation on sets, that is union, intersection and difference, right? Union, intersection and difference of two sets, right? In the next lecture, we will be continuing with what is left in the chapter and probably The next lecture, we will try to finish it off. Let's see how it goes. But hopefully, you are getting an idea of how exactly set is to be understood and how to solve questions related to sets, right? As I said, that this gives you a broader perspective of understanding, collection of objects in a better way. So it is going to be very essential. And this entire learning that we are doing is something that we will be also using in the chapters to follow. Let me give you a sort of idea that we use the concept of sets in chapters like permutation combination, in chapters like probability, and so on, right? So the concepts of sets is used extensively in these two chapters. At the same time, we will also use the concept of sets while defining relations, while defining functions. So this chapter is very important because it gives you a basic understanding of relation and functions, right? Because we define relation and functions in form of sets. So I hope you are able to understand whatever we are going to learn here, and then we will be using this learning in the chapters to follow. So see you in next lecture. Keep working hard, be confident, and try to learn as much as you can, not just for the sake of solving questions, but for the sake of understanding the concepts behind it. Okay, thank you for watching. Do share and subscribe these lectures with your friends because it is going to help them as it is helping you to get the basics of all the concepts right. All right, see you in the next lecture. Till then, keep working hard, be happy, be stress free, and see you.